Okay, we're going to look at histograms, dimensions of bars. This is a really common exam question. Okay, do you remember in that first video, the lady said that the area of a histogram was proportional to the frequency. When we've got a histogram, I'm thinking this is the base, isn't it? And this is the height, and this is the frequency. And how do we find the frequency? We do base times height. And the height is sometimes known as frequency density, or FD, and so frequency density is often found by the frequency. Well, we don't really call it the base, do we? We tend to call it the class width divided by the class width. Now, frequency density, or the height, is the frequency divided by the class width, but because the frequency is proportional, they can do anything they like to it. So they could double everything, or they could times everything by 10. So it's not always the case that the frequency density is the frequency divided by the class width. Sometimes something extra happens to it. So this is an example of something extra happening to my bars. Now, the first thing that I want you guys to do is I always want you to check for gaps. Now, I know this sounds a bit strange, but if you get this wrong, the whole thing goes wrong and you lose all your marks. So histograms are about continuous data. So there are no gaps between any of the bars. Now, if you notice here, do you notice there's a gap between 15 and 16? So in fact, the bar going from 10 to 15 doesn't go from 10 to 15. It goes from 9.5 to 15.5. We do what's called close the gap. We go a half below and a half above. And in fact, the bar going 16 to 18 will go from 15.5 to 18.5. And this bar here will go from 18.5 to something we don't know. So always check and see if you need to close the gaps. Sometimes you will, and sometimes you won't. Okay, right, let's begin. So they're going to tell me some stuff about a histogram, and what they're talking to me about is they're talking to me about the 10 to 15 one. So I'm going to concentrate on this 10 to 15 one, that's this one here, and I'm going to pop some information into my histogram. So what they are telling me is they are telling me that the width is 2 centimetres, all right, so from here to here. And they're also telling me that the height is 5. Now, if we think back to our histogram, what else do we know about it? We know that the frequency is 15, so I'm going to put the frequency in here, and we know that the bar goes from 9.5 to 15.5. So if I was graphing it, I'd start it off at 9.5 and I'd finish it at 15.5. Now, the trick to this then is that we then change pen colour and we write down what we think it would be. So that's what they've graphed it as. They've obviously scaled it and done something to it, timesed it by something. I'm going to have a think what I would graph it as. So if I was graphing this histogram, I'd graph it from 9.5 to 15.5 wide. So I would graph it 6 centimetres going across. Now, what would I graph the height as? Now, the height here, we said the height is found by the frequency divided by the class width. So I would call this, in fact you can call this frequency density if you like, that's first frequency density. It's the height, it's the frequency, which is 15, divided by the class width, which I think is 6. So in actual fact, I would graph it at 2.5 centimetres tall. Okay, so that's kind of the first one. Then we go on to the second histogram. They are talking to me now about the 16 to 18. So let's go down here. So I've got a bit of space. So this is now the 16 to 18. Right, let's put in what they think it is. So they think, well, in fact, they don't know. So I'm just going to put that as a question mark. That's my question, isn't it? Find the width. And I've also got to find the height. So I don't know what they would graph it as. So let's put in what I do know. So let's go back here. What do I know about this histogram? 16 to 18. Okay, here's the 16 to 18 category. I know the frequency is 9, so that can go in here. And I know it goes from 15.5 to 18.5. So I would graph it at 15.5, 18.5. Okay. So let's have a bit of a think. I would therefore graph it 3 centimetres wide. Now, what would I graph it if I was doing the height? So the height is found, I could call it the frequency density, couldn't I, if I wanted to? I don't often actually call it that, but anyway, frequency density, it's found by the frequency divided by the class width. So it's 9 divided by my 3, which gives me 3 centimetres. Okay, let's move that up a little bit. Right, now the rest of it is very simple. Let's have a look at the bottom. You then circle the widths and you create for yourself 2 little fractions that are equal. So from there, 2 over 6, that's that bit, is equivalent to question mark over 3. And if we times up, 2 over 6 times 3 gives me my question mark, and therefore my width is coming out as 1 centimetre. All right, that's my width. You then do exactly the same for the heights. So you circle around the heights and you match them up. So 5 over 2.5 is equal to question mark over 3, and therefore question mark is 5 over 2.5 times 3, and therefore the height that they think they've drawn it at is 6 centimetres, and that's it done. Okay, you see if you can have a go with the same question, but I've changed some of the numbers. All right, have a go and then check back and see the answers. Okay, here's the answers. Were you right? Width of 1.5 centimetres and a height of 6.6 recurring centimetres.